Hello, this is Dr. J, and you are watching week 3 for the course Introduction to Anthropology. Hello, this is Dr. J, and you are watching week 3 for the course Introduction to Anthropology. During this week's lecture, we will be talking about the genus Homo and all of the primate evolution that led up to the emergence of the genus Homo. It's a pretty dense set of histories. Strap in, it's going to be a pretty intense lecture. We look basic high school biology. We have the separation of the animal kingdom and life into various different domains, kingdoms, phylums, classes, orders, families, genus, and species. If this was a physical or biological anthropology class, that might be something that would show up on a test somewhere. You'd have to memorize that. That was something that was very important for all of the biological and physical anthropology courses I took as an undergrad. But what we see here is a overarching category or categorization of species that includes many different species and many different kingdoms and phylums and classes and orders. And we see a slow narrowing in on specific sets of descent. This is more or less one way that we can use to organize a family tree over time. Primates in general are categorized as everything from apes, which includes humans. We are an ape, to more simple monkeys such as lemurs and lorises. Tarsiers, New World monkeys, and Old World monkeys have some very distinct differences, even though they look very similar as species and anatomically and phenotypically. There is some noteworthy differences. And then even among apes, we have a large diversity of different types of apes. These species are the sets of species that are most closely related to humans through evolution. And we can see getting to the chimp and the human as being very close common ancestors, as well as the human and the orangutan are close ancestors as well. Very different style species. So we'll talk a little bit about that. Primates, all of these are primates, monkeys and apes. And it's important to see a difference between apes, this sort of higher form of primate. Just some ways that we can talk about differences between Old World and New World monkeys. New World monkeys would be those monkeys that are found in the Americas, and the Old World monkeys would be the monkeys that are found in the Old World, Africa, Europe, and Asia. There are some distinct differences we can see in the common squirrel monkey. I actually am pretty familiar with squirrel monkeys. They are not as happy and giddy as you see in this picture. They're very small, and I think they're scared to death at all times. That's their evolutionary function, is just to be really scared and small. They're smart and they're sweet to interact with. I lived on a zoo for about 6 months. We had a lot of squirrel monkeys. It was in Bolivia. And we also had a number of spider monkeys and capuchins. All very smart. They had prehensile tails. All of them had prehensile tails. So you can see this sort of curly tail they can use to hold things, pick up things, and sometimes even hang from them. We can see that they are small to medium sized. So we don't see these human sized primates or anything that even gets to the size of like a Great Dane or the size of a German Shepherd or anything like that. Can see that they mostly have flat noses. New World monkeys have flat noses. So that means that their nostrils tend to be faced more so uh, outward. And then we see that or sideways that we see in this graph here, they have a 2-1-3-3 dental formation. So they have uh, two incisors, two canines, or excuse me, two incisors, one canine, three premolars, and three molars on 1/4 of their dental plate. And we'll talk about that a little bit differently, but that compares to the 2-1-2-3. So two incisors, one canine, two premolars, and three molars. That's the same dentation that we have as humans. If you compare human dentation to dog dentation, there's a lot more teeth in that dog. Same thing when you look at fish and other types of distant species. Just the amount of teeth and the structure of teeth are so incredibly different and unique among those species. And even between these monkeys, Old World and New World, as well as the similarities that they have with humans, is just really impressive. And then we can see that they are primarily arboreal. So that means tree dwelling. So they're arboreal and they live in the trees, whereas in the Old World monkeys, there is a more varied and variety of habitats. Apes versus monkeys is another way we can see this. Old World, New World. Apes versus monkeys is another way we can see this. So apes tend to be the higher form of primate, once again, the more intellectual primate, the larger in body primate as well. They use various different types of locomotion, brachiation, so swinging from branch to branch instead of just jumping from branch to branch, is pretty common among orangutans, but we don't see it in other types of species. You can see that apes have larger brains. We can see that they have broader chests and bigger shoulders, most likely because they're using their hands to manipulate things in a little bit more frequent and intelligent fashion. So they're sort of standing upright. They can be bipedal. They can walk on 2 feet. And then they don't have a tail. Whereas if we look at monkeys, monkeys have tails. Old World monkeys don't have the prehensile tail. We see that the New World monkeys have that prehensile tail. They tend to have a smaller brain, narrower chest, smaller joint shoulders, looking like we're walking on fours and we're using all four limbs for locomotion most of the time. Capuchins, I mentioned these. These are a species of monkey in the New World. So they stretch from Central America to Argentina, almost all north to south of Latin America. You might also recognize this species from the television show Friends. Often in Hollywood, they use adolescent or infant capuchins because they're really docile and they're really sweet and they're very easy to control and convince. Once they get to adults, they get sort of crazy. I worked on a refuge in rural Bolivia near Santa Cruz, sort of in the rainforest, as well as the connection between the Andes and the Amazon, very interesting region there. And a Swiss woman started a refuge for monkeys. And so people would be domesticating capuchins and not wanting them once they reached adolescence. So she would always just be receiving these adolescent or adult capuchins that were not ready to go back into nature. She constructed this huge cage for them. It was a cage more or less, but it was like a basketball court size cage for about 10 of them. So it wasn't the worst, but it was just sort of a necessity for the experience. But they're really smart, really emotional. If you've never interacted with a monkey or an ape before, my experience interacting with capuchins is pretty significant for me. They know names and people. They understand a whole variety of words. I had one who was an adolescent. She would always go into my pockets and steal my change and then show me that she was holding my change. And she would always be able to get really close to me because she was an adolescent and she was still sort of docile and she wasn't forced into the caged environment yet. But if I would go into the cage, it's like, don't bring anything into the cage. They're going to steal stuff from you. They're going to find that change on you. But really smart, really, really intelligent, very much group creatures, very social. And to domesticate them, sort of cruel, but they're interesting and fascinating just in terms of how close they are to humans. Okay, New World monkey. Then you see here prehensile tail. You can see some really cool, gnarly looking hands right here, but they still don't look very much like our hands. The thumbs are a little bit longer, right? You can look at the face here. There is a smaller brow ridge on top. And then you also have those sort of outward facing or sideways facing nostrils. And of course, this eye cavity that's a lot smaller than what we see in humans as well. Gibbons are, in terms of apes, the lowest form of ape. They're the most monkey-like ape if we look at in terms of evolution or in terms of even just appearance. Here are one type of gibbon. They're distinct for males and females being different colors. I believe the males are the lighter and the females are the darker ones. There's three different subsets or four different subsets of gibbons, and they're all very much endangered because this, if you notice on the map where they're inhabiting Myanmar, Laos, Cambodia, Vietnam, Thailand, Malaysia, Indonesia, all of these are very densely populated Asian countries. And you can just imagine the encroachment. They need a lot of space. They need a huge amount of space. They need a nature reserve to go and hunt and gather and do their thing and have just sort of their own social space. That's all getting encroached on. So gibbons are incredibly endangered, and all of these countries are sort of trying to come together and give them some refuge as well. Here we can see just some interesting things. This was actually put together by a Chinese NGO or Chinese Nature Conservancy, and they're talking about China's southern island gibbons and just giving some really interesting facts here. So we see that there is a critically endangered species. They have only about 30 individuals left. They live in social groups and form well-established territories under threat from habitat loss and fragmentation. So with humans, we sort of build bridges and we build lanes and we just sort of threaten the ecosystem that's really necessary for these species to thrive. They have difficulties in dispersing from each other when needed. So they sort of just really hang on to each other. If there's a threat, that could be really bad because there's going to be a large population that's just like not in a safe place in relationship to humans. Loss of energy efficiency. So it's becoming a lot less forested, right? Breeding opportunities when there's fragmentation, they can't be social and meet up with one another. Predators and disease and parasites and all these kind of plagues that will just wreck a population of 30 individuals. And then we have just some very interesting facts. So we can look at all the different forms of locomotion that are common for gibbons. Here we have climbing, we have walking, bipedal locomotion, we have a different form of underneath climbing, so hand railing versus climbing, and then we have swinging brachiation. And if you note on here, you might be able to see on the screen there's this child holding on to the adult who's swinging. There are then orangutans. If we go to the next set, orangutans, they live about 50 years. They got a really nice, healthy life. You can see a little bit of a sexual dimorphism here, sexually dimorphic. So when you have two different sexes, they tend to be dimorphic. They tend to be different, right? There's a differentiation that we can note in the animal kingdom. The female orangutan often is much more gracile or smaller. The male orangutan is much more robust, has these huge cheek pads or flanges. We can see also that they just have more mass. They can vocalize and they often need a lot of space. They generally don't live together. The female often cares for the kids, and then the male goes off and does his own thing. So you see sort of this need for space out there in the forest, fragmentation. When that forest gets fragmented, it becomes really problematic. Orangutan translates to man of the forest. I have no idea what language. They're principally on Sumatra and Borneo, so that's Indonesia and a few other countries that share those islands, smaller countries. Tropical rainforest, most living off the ground in trees, so they make tree-type nests. And then we can see there's only about 50,000, a little over 50,000 between Bornean and Sumatran types of orangutans, and they differ slightly as well. Diet is 60% fruit. The rest comprises young leaves, shoots, a lot of fiber, stuff like that. They're pretty passive and pacifists. They're not really fighting a lot. Look at the gorilla. This is also a very recent evolutionary ancestor that we can see. Species of gorilla. There's 4 different types spread throughout that sub-Saharan region, going from the eastern lowlands to the western lowlands. So these are lowlands, and then you have mountain, and then the Cross River tribe, which is in blue, which is in Nigeria and Cameroon. And then you can see the western lowlands are principally in Gabon, and then the Democratic Republic of Congo has a significant number of gorillas as well. Things to note: they're knuckle walking. They're walking on their knuckles. These are all, from what I can tell, maybe this one in the corner is a female, but you can see these significant sagittal crests in the males, like these just huge, bulky heads in the males when compared to the females. First gorillas seen by Westerners supposedly were in 1847, at least in modern accounts. There was sort of this 1,000-year ignorance of gorillas, even though they were side by side with humans for a long time. So we see that possibly in Egypt, they were trying to sail around the eastern coast of Africa, and they may have encountered some gorillas. And then there's also the possibility that Carthaginians did that as well. And this was going back ancient Greek times, right? So more than 3,000 years ago. But other than just some scattered documentation of these creatures, there hadn't really been a lot known up until about 150, 200 years ago. This is one of the first encounters, my first gorilla, someone shooting and hunting a gorilla, right? Horrible things that colonialism and Western exploration did. What to expect from a Congo gorilla? This is just a tour. People do tours of gorillas. I worked at this Capuchin refuge in Bolivia, and we funded it in part by giving tours to people who wanted to see, like Westerners who were just like, oh, let's just go see a bunch of monkeys. And, they would pay to come in, but it wasn't necessarily a zoo, right? It was sort of this alternative mission that we had. Similar with a lot of these gorilla tour guides. You're not allowed to hunt gorillas anymore, obviously, because they're highly critically endangered. There's only about 100,000 individuals living in nature. They live in small family groups, average 4 to 10, sometimes called a harem. Most of the time, it's going to be one dominant male with a harem of females. And then we might see a younger male, but often there's this conflict. Males are often in conflict. And you can see that there's this rule: stay about 7 meters away. They're not prone to violence, but they're big, bulky animals that can weigh up to 200 kilograms, so more than 400 pounds. They can definitely rip your arm off and beat you with it if they wanted to. They just don't necessarily have the disposition to do so. So big creatures, twice the size at very least of a large human being. Then we have bonobos. These are once called pygmy chimpanzees. So they're smaller in stature. They often have more hair, and you can see they sort of just look more gracile. They look more diminutive, and they often live in very tight-knit matriarchal groups. and they resolve most of their conflicts through copulation and physical affection. So there's sort of these hippies that just sort of try to calm one another at all times through physical affection. Pretty problematic. Population's only about 10 to 20,000. I grew up in Milwaukee. We have the largest population of bonobos in a zoo outside of Africa, and it's a very peculiar population. They look very much like chimpanzees. They tend to be smaller, and this population in Milwaukee, the one that I was growing up with and going to the zoo and seeing, they would pick out their hair. And so we have this bald population of bonobo primates, which was just bizarre. And no one really knows why. I've talked to primatologists after, studying anthropology in the city and then also working with a number of anthropologists. I asked many people, why are they picking their hair? And I've heard everything from they want to look more human to anxiety to possibly there was a health reason, like they got ticks or something like that a few generations ago, and then they just started continuing to take out their hair, right? So all these different random ideas, but really bizarre to just think what is motivating these really human-like intelligent creatures that are highly endangered. 66 to 130 pounds, about half the size of a human, or 2/3 the size of an average human. Compare this to bonobos and chimpanzees. You can see that chimpanzees tend to add about 50, 60 pounds, depending on males or females, and they can get up to like 200 pounds. This is just average, but they can get big as well. And you can just see the broader shoulders, the taller height, just a bulkier primate. And they tend to be a little bit more intelligent. They tend to be a lot more violent as well. So here's just an image of the hairless bonobos at Milwaukee's zoo. So you can see that these kids are just hairless, and they are just constantly picking hair off one another. And the adults look like this, as well as these children. So, and this is what they look like in the wild. So just a comparison, right? Very different, very social creatures too. Might be just a way, if you look at most creatures, they will kill any bugs that land on you. If that dog or that cat likes you, they're there to protect you, right? And I think some of the things we do, like pet dogs and stuff, that is a form of grooming and affection. And I think that's something that's pretty universal. So seeing these hairless bonobos, I think could just be a way that this small population has chose to interact and be friendly with one another. And possibly, I'll just assume they might have also been discouraged from being sexual and physically affectionate, which is sometimes their practice in nature, even when it's among family groups. They don't really have a taboo when it comes to incest, for example. So we see bonobo region much more isolated, and then the chimpanzee region in Africa, still sub-Saharan, but it's a lot more extensive here, and it sort of encapsulates this bonobo region. They do run into conflict. They don't interbreed. So bonobos and chimpanzees, we can see that bonobos here on the left are friendlier. Chimpanzees look a little bit more angry. Height difference, weight different, character and behavioral difference. You'll see chimpanzees will kill one another very frequently. That is not the case when it comes to bonobos. We can see that there is some intelligence, some more advanced intelligence with the use of tools to fish out ants and bugs and try to dig out fruit and stuff like that. And then we see that sexual behavior, copulation is frequent with the bonobos, and with chimpanzees, it's like only for procreation. It doesn't seem like there's a whole lot of social aspect to it. And if we look here too, we're now pretty familiar with orangutans, which broke off from our human descent, but that makes us also one of the closest related ancestors to orangutans. And then we see gorillas, which broke off at a different time than when the chimpanzee and bonobo broke off. And this is going through about a 12 million year history. anatomically modern humans emerged about 4 to 5,000 years ago, or excuse me, 400,000 years ago. And 4 million years ago, we start seeing some of the earliest antecedents to the anatomically modern human line. So, once again, chimpanzees here, these are our closest animal relatives, our closest living relatives, very social, very violent. They are matriarchal, but there's also a common thread of males. There's this highly complex social environment. I can see here Jane Goodall was one of the most significant advocates for chimpanzees. On the right was when she was a little bit younger, I believe in the 1960s, when she was in her 20s, when she started doing conservation work living with chimpanzees. And she was young. She just had an undergraduate. She wasn't a master's or PhD student, and she just jumped right into the research and went and lived with a population of chimpanzees. And here you see on the left, she is much older now. She's 50 years older, and there is an old, withered chimpanzee before and after. That whole time that she's been working with and investing in these chimpanzees, you can just see these human emotions that are getting expressed. Like, it looks on the left like two old ladies gossiping about good old times, right? And then you see on the right, you see a group of individuals, friends, possibly cuddling one another, right? Or showing some form of reassurance to one another in just a very sweet moments, right? Just these very human emotions. And I think that's something that everyone always notes when they talk about interactions with chimpanzees. It's not just the intellectual capacity, which they do have a high intellectual capacity, and this sort of mirror into the soul, the evolutionary soul of humans, but it's this emotional content. And I think Jane Goodall did a really good job bringing that out. So they are a hominoid, so that includes the lesser apes, like the gibbons, the greater apes, like the chimpanzees and gorillas, and then humans. We sort of form this hominoid superfamily. Different word, hominid. So we have hominoid and hominid. Hominid is the group consisting of all modern extinct great apes. That is, modern humans, chimpanzees, gorillas, orangutans, plus all their immediate ancestors. So I showed that evolutionary tree. Going back, there was different iterations going back in time. And so this was referring to all the evolutionary antecedents to the current group of great apes. And then you have hominins. So hominoid, hominid with a D at the end, and then hominin with an N at the end is the group consisting of modern humans, extinct human species, so like Neanderthal, for example, and all our immediate ancestors, including members of Homo, Australopithecus, Panthropus, and Ardipithecus, which we'll talk about all those. And it's sort of the early cavemen that we see in evolutionary history, all the way up until who we are right now, which is the anatomically modern human. The oldest apes that we've been able to possibly find are 25 million years old, or you have here 25 MYA million years ago in modern day Tanzania. We only had this little jawbone, but as I was saying earlier, you can extrapolate a whole lot just from having a few teeth. We know all this stuff about teeth. If you have one specific shape or type of tooth, that tooth normally doesn't exist anywhere else in nature. That's something that's really species specific. And if you can extrapolate a jawbone, then you can extrapolate what other parts of the brain and what other parts of the cranial capacity exist. And then you can understand going and looking at where the spine meets the skull. And then you can just extrapolate and go down, and you can compare it to other elements of the fossil record as well as other elements of the existing natural record. So we see here one of the oldest apes. This is sort of the earliest ape, and I'm going to be slaughtering some of these terms right now, but Rhacquapithecus flagelii is the oldest one that we can see. And they extrapolated this. They found it in a cave in Tanzania, and they extrapolated all this information from what we see. 25 million years ago, they're most likely small forest creatures, nothing like the great apes that exist today. Human evolution, modern human evolution, goes back about 10 million years in Africa. We can look at climate change, and we can see the emergence of these human-like creatures sort of getting out of the trees and walking on two legs and starting to travel around and dominate the world. And what we can see is that during the 10 million year ago point, that these arboreal primates separated from the terrestrial primates. So arboreal will be the tree primates, and then those are in the west part of Africa. And then we can see the woodland and savanna on the east part, and that's where we start seeing a lot of the process towards evolution is in the terrestrial part of Africa, where these huge tropical forests withered away and became savannas and woodlands, so lower. So there was this greater need to travel, and there was this huge threat by megafauna, like huge birds and other types of cats just sort of hunting down these primates. And so they had to evolve into these quick bipedal creatures, a constantly changing environment, and it spurred a whole lot of evolution really quickly. So some of the earliest primates then we can see, just going back and sort of doing a review, we're going and seeing the common ancestor. What's this common ancestor, this flagellii that we see coming out of Tanzania? That's a common ancestor that we can see. And then we can see the contemporary animals. So humans in this context is an animal, right? And then we have this sort of spotty record in between. Of course, the impossibility of collecting a set of fossils from every single descendant of flagellii, that little jawbone that was found in Tanzania, over the course of 25 million years is an impossible task. There is no way that those descendants are going to be just laying down next to each other and giving a really adequate fossil record. So a lot of people critique the concept of evolution and this idea that we descended from apes as this sort of fantasy, because we don't have this one really complete, legible line from point A to point B in the fossil record. But that's just something that we are motivated by now, and we got to find more fossils, and we got to find more proof that this is a very valid connection. Here we can look once again, just breaking down. So we have these prosimians, lemurs, lorises, potots, tarsiers, New World monkeys, all the way up until the great apes. Once again, a family tree. But what we see then is a push in this family tree towards bipedalism, towards walking on two legs. And the question is, why are we walking on two legs? Why are we pushing towards walking on two legs? We're carrying babies, possibly, so that's traveling a lot more. So we got to pick up kids and walk with them while they're very vulnerable and they're learning, right? We have these highly complex brains. Chimpanzees, orangutans are all very useless up until they get to 3 or 4 years old, and then they can start walking and stuff, but they're still sort of useless and they need a lot of protection. We can look at making tools, maybe intellectual and scholarly capacity, and just the ability to create systems in our brains became so advanced that we started to make tools and adapting to environments with our brains instead of our bodies. Thermodynamics, if you are walking for long distances of time in a savanna-like environment, you're going to get warm. So what you want to do is limit the amount of contact that your body has with the sun. And by walking on two legs, you are just sort of having the top of your head, which is pretty tufted hair, right? Why do we still have hair? Possibly because we are worried about thermodynamics, protecting our head a little bit from that sun that comes from above. And then we also have just the shoulders that are getting hit with the sun. We don't have all our back and our legs getting hit. So long distance, better thermodynamics. We can walk a little bit easier as well, too. We are producing less heat. We are creating a more sustainable form of travel. If you look at who we are as a machine, right? The human machine. We want to wade along shorelines. If you're traveling, you got to cross rivers. Some species don't know how to cross rivers. Some species don't know how to swim. And so they need just sort of like an act of God to send them over to the other side of the river. Whereas humans and our ancestors went about trying to find a way to wade along the shoreline. And then once again, more efficient movement, just in general, just being bipedal gives all these benefits of having different types of efficiency to our body. What are some evidence that we can see of these changing elements or things that we can determine also through the skeletal record? So we're looking at bipedalism. We're looking at this evolutionary path from knuckle walking or whatever our earliest ancestors were doing, our earliest primate ancestors were doing. And then what was the evolutionary path to have us walk upright? And our pelvis changed. The whole dynamic of our body changed as a result of shifting to bipedalism. We can see some very specific things when we look at the skeleton. We can determine sex often. We can look at that through the pelvic bone. We can look at age, bones, as far as I understand. I'm not an expert at osteology, but as far as I understand, bones form like trees. And so you can sort of determine how old bones are by how they sort of wither away and grow like trees. You can look at race and species, specifically looking at the race or species of a specific animal, not necessarily within the human species. We'll talk about that a little bit later, why that might be sort of problematic using a skeleton to talk about race. Then we can see some pathological conditions, illnesses, or scoliosis, for example, a deformation of the skeleton in some way. And then we can also see skeletal trauma, like things get broken. Teeth, you can see people having sort of these ground down teeth in the back from making leather. They use their back teeth to sort of straighten out leather. So we can see trauma in a bunch of different ways, violent trauma, but also like what work were they doing? Were their hands all calcified, and were they traumatized from doing hard work with their hands? Or what were some of the conditions? What weight did they have, right? Were they overweight or underweight? All that kind of stuff. Australopithecus afarensis, Homo erectus, and Homo sapien. This is more or less the path that we are going to be tracking from now on. Australopithecus afarensis is one of the earliest early modern or early Homo, pre-Homo skeletons that we can see. It's Australopithecus. So it's not the genus Homo, it's Australopithecus, which is sort of the species that became, or the set of species that really looked like they led to our anatomically modern human hypothesis here. So we can see some sagittal crests here, some occipital lobes. So you have the crest here. It's good, sort of pointed out. You have the lobes, the eye sockets here are also a lot more pronounced. And then you also have this sort of jutting out of the jaw, these much more robust, much more violent looking teeth. And you can see here going towards humans, cutting through Homo erectus, going through humans, much larger brain, just sort of a slow process to get to that brain. You see teeth sort of straightening out here and looking a little bit smaller. They're getting a little weaker. We don't have to have these big old teeth because we're processing our food more. Same thing with our jaw, looks a little bit more gracile that we can see. And then our brain just is much larger and much more dome-like. And you compare these to the chimpanzee, and even between the Australopithecus afarensis and the chimpanzee, using these qualities of like the bones, the mouth getting smaller, the head getting larger, the eye sockets getting a little bit more sunken back in, and the brow getting a little bit taller, we can see that the chimpanzee looks downright primitive compared to the Australopithecus. Some primate characteristics and trends, then once again, larger brains, larger than other animals. You can see the tarsier, this sort of lower level monkey. Lemurs, once again, lower level monkey. Chimpanzees, now you see starting to see a little bit more folding in the brain. And then humans, you see this just large capacity, 1,400 cubic centimeters compared to 3 cubic centimeters in the tarsier, which is like the size of, one 1/1000th of our brain, or not 1/1000th, 1/300th of our brain, or something like that, right? So we have this just excellent cerebral organ to process information and to just really think through problems and create systems. And you can just see the folds and the density of that brain, and how it just gets more dense and dense and more compartmentalized over time, comparing to the olfactory bulb, so like the smelling cerebrum, where all the nice thinking and memory takes place, cerebellum, logic, and also balance. And then you have the occipital lobe, right? The seeing part of the brain, and all of these things are becoming much more complex and much more evolved, alongside a body that is becoming much more aligned with bipedal hand use and tool creation. Looking once again at the fossil age compared to brain capacity. So this is also something we can think about. So the oldest fossils have the smallest brain capacity, and the newest fossils, especially when we go along this evolutionary path, the newest fossils have a larger brain capacity. So fossil age, a million years ago, 8 million years ago, less than 500. Closer to the present, Neanderthals actually had a larger brain capacity than anatomically modern humans or Homo sapiens. Just sort of a weird, sort of isolated incident in evolutionary history, and we're still not necessarily sure why Neanderthals had larger brain capacity. They might have been smarter. They might have had a larger, different aspect of their brain. Their cerebellum might have been larger than their occipital lobe, or something like that, right? So we're not exactly sure. We don't have a nice, well-preserved Neanderthal brain to understand what exactly was happening in this process. You could also look at dentation. Once again, we are looking at that 2, 1, 2, 3 in anatomically modern humans. Old world monkeys are going to have 2, 1, 3, 3, 2, and you can look at your own mouth. If you have all your teeth on at least 1/4 of your brain, you have your 2 incisors, your 1 canine, your first and second premolar, and then your 3 final molars. And then you also have a wisdom tooth, and most people get that wisdom tooth taken out if they can. And so you can see that's sort of duplicated throughout the mouth. We got that happen 4 times throughout the mouth. And you can just look at just the different configurations that we have here. Let's just count. Look, we got 2 incisors. Looks like we have 1 canine, and we have a 2, 3, 2, 1, 2, 3 dentation here. Let's see. Okay, one more time. 1, 2, 1, 1, 2, 3. Once again, we have this 2, 1, 2, 3 dentation. So all these are 2, 1, 2, 3 dentations. I'm not exactly sure what species they are, but I'm going to just throw this out there and say that this one is most likely going to be like a gibbon. This might be a chimpanzee here. This might be something like a Homo erectus, because we don't have a complete skeleton, right? We're missing these 3 teeth here. Might be something else like a Neanderthal. And then here we have a anatomically modern human. So some other things that we can see as well too, just like the foramen, where the spine goes into the skull. You can see that's moving further and further into the center of the skull. See some brachiation take place, right? So we're talking once again about movement. So we're looking, okay, what's happening? If you just look at what's happening when we are shifting towards bipedal locomotion. So we have on the top these leapers. I think those are tarsiers, lumping from one tree to the tree. You know, you really have this need for a huge tail to balance. It looks like a baboon on B. Let's see. Yep, it's a baboon on B. And you can see some sort of quadrupedal walking that's taking place, this nice broad back. We have some brachiation taking place with the Siming, which is a old world monkey. And then you have bipedal locomotion. You can just see all the different postures, right? Here's another way to sort of think through this. We go from knuckle walking to bipedalism to human bipedalism. So when chimpanzees or gorillas are knuckle walking, you can look, it's almost like their whole back is exposed to the sky, and they're walking on their knuckles here, right? They're sort of making fists and walking on those, and they can run really well. They sometimes do bipedalism, and they have some ease at doing so, but only really in short bursts and to manipulate the world around them. It's not necessarily a type of locomotion. If they're trying to run and go quickly, they're not going to be on 2 feet. They're going to be on four, and they're going to be knuckle running, compared to bipedalism, which is sort of to pick things up and maybe pick up babies or something like that. So we have both knuckle walking and bipedalism. Just looking at the angle of the hip to the ball of the foot, where all the weight's getting distributed, you can still see that within the chimpanzee, the hip to the ball of the foot is way off center. So the chimpanzee or the gorilla is going to have to sort of walk hanging over their legs, whereas humans are walking on top of their legs like a platform. So just the basic thermodynamics and the engineering of it all. Brachiation, some things that might have helped facilitated some human evolution along the line there. Brachiation, as species like orangutans and our common ancestor were brachiating, most likely. They were developing a much more complex brain that worked in stereo vision. It's not just jumping from one platform to another. You're working in 3D, and you're trying to get a mental map of your 3D environment as you're moving, right? And you're sort of using two different limbs, swinging, you're doing calculus in your brain. And the eyes need to be a lot more attuned to that type of movement as well, or else you're going to smack into the side of a tree. So possibly when we're using these other types of locomotion, we have this built-in evolutionary capacity to adapt and invent just new forms of moving around. Once again, here we can see just the nature of the spine. It becomes much more bouncy in the humans when compared to the chimpanzees or gorilla, which looks a lot more straight, right? That's definitely a result of more weight just getting compounded on the hips, opposed to being distributed across the shoulders and the hips. And then you can also see the necessity of chimpanzees to sort of duck walk. They sort of have this hips that's much better made to walk on all fours. And so they are going to be using those short, sort of awkward legs in a little bit more of a squatting, hunched over type of walk when they're bipedal. When we compare that to Lucy, I'll talk about who Lucy is here in a second, but Lucy is an Australopithecus. She is one of the earliest complete specimens of the Australopithecus that had been found in the 1970s. And she was also one of the first bipedal species, principally bipedal species that we can see. And if you just look at the nature of the hips, they are a lot more pointed out opposed to pointed down. And the whole structure of the leg just looks a lot more geared towards walking in a hammer-like bipedal motion that we're accustomed to nowadays. You can also look here at the different types of feet that slowly evolve, and this is something that we can see evolving over the evolution of anatomically modern humans. You can see here that there is a foot here with sort of a thumb-like toe, and if you look at that compared to our toe, our big toe, there is a still more pronounced toe, but doesn't necessarily have that same implicit ambidextrous or tactile function. You can't necessarily pick things up, whereas a chimpanzee can pick things up. So three things, right? We have the femur and the pelvis that are dead giveaways for the advancement of bipedalism. And then we can see this foot slowly becoming much more of a shoe-like thing than a glove-like thing, right? We sort of are having this hoof-like process that's getting formed where we're using this organ principally for locomotion and not really for anything else. So all of these sort of dexterous features are going away. Also look at the proportion of different bones. So the anatomically modern human humerus is a lot shorter and a lot less robust than it is in the apes, in the gorilla and the chimpanzee. In contrast, the femur in the anatomically modern human is much more robust than it is in the earlier apes because majority of that work is taking place on those legs. That physical work is taking place on those legs. Once again, the foramen magnum, we can see it slowly creeping towards the center of the skull. This is going from a chimpanzee to a anatomically modern human, slowly going towards the center of the skull. The skull is no longer sticking up, but looking straight forward. Once again, foramen magnum shifting here, chimpanzee to the Australopithecus afarensis to the Homo erectus to Homo sapiens. And once again, we can see trauma taking place. We can see if people died violently. We can see if people were malnourished. We can see if their skulls were malformed in some way. We can see if there was any type of healing that took place. This is a skull from Peru. We can see an early form of brain surgery taking place. More or less, they would punch a hole in the skull to alleviate fluids. And they had a very well documented history of doing this in the Andes for thousands of years. So this is just one real explicit example of evidence that we can find to determine trauma in a skeleton. Hold on, everybody. I'm going to be right back in 1 second. I am just going to go and turn off a light here. Okay, everybody, I am right back. Sorry about that. Switching to the next slide. One of the possible common ancestors between humans and chimpanzees, of course, we don't know definitively if this was the ancestor, if this was one that sort of branched off and inherited more of the traits of the chimpanzee or the human, who knows? But 7 million years ago, we're seeing this common ancestor that shares traits between humans and chimpanzees, sort of this really close common ancestor. And we can look at the teeth, we can look at the shape of the skull. Obviously, this skull that's on the screen is one that had been pieced together. Often they find these skulls in like mining sites or places where the earth is already just getting like chopped up, and they find things that look like skulls, and they're like told to keep an eye out for those things. Those things might be very valuable to somebody, and so they stop things and they go and they dig out those skulls or those bone fragments as best as they can. Sometimes they do more of a archaeological examination of things or a paleontological examination of things, like you would see in like Jurassic Park. So they find like evidence of a species, and then they'll just keep on digging down into the earth. But this one, the Sahelanthropus chadensis, you can see it's Sahel, which is sort of the sub-Saharan Africa region, and that is in Chad. The specific species was discovered in Chad. Some of the early hominins. So remember, this is the species that is directly related to humans and no other species. Hominins. Hominoids are the broader great ape, including human category. Hominids with just a D and not oid, but nids, just with hominids, is the current group of great ape species. And then we have hominins, which is the ancestral line that most likely contributed to anatomically modern humans. The earliest that we have in that line is the Australopiths. So two common trends that we can see, they go from being gracile to robust. So gracile just means thinner bones, less powerful jaws, probably ate more fruits and insects, versus more robust. We see thicker bones, more powerful jaws, ridge crest on cranium, flatter teeth, seed crushers, fibrous materials, leaves. They're just eating leaves. And so you think you see this more robust skull, and it actually signifies that they are chewing. If you ever see a cow skull, it's sort of got a very similar ridge to it, and it can look very aggressive and very dominating, right? Very powerful jaws and powerful teeth. But those are indications that the Australopiths, a group of them, sort of hung out in the trees, and they didn't go out into the plains and the savannah. So they didn't necessarily have that impetus to evolve. They were more or less just like gorillas, just sort of eating leaves in the environment. Southern ape of Africa, Australopithecus afarensis. This is the first species in the Australopith line that we can go and analyze or refer to most frequently. This is Lucy, the skull of Lucy. You can see just in the hands of that individual holding it that the skull of Lucy is much smaller than the average human skull. Lucy was a full-grown adult Australopithecus afarensis, or southern ape of Africa. Lucy was discovered in Ethiopia in 1974. You can see just these fragments on the far left. The image in the center compares the fragments that were found and the supposed construction or makeup of Lucy's body compared to anatomically modern humans. So sort of missing some things, but we can just see by the way that the skull is shaped and in reference to these other chadensis and the other species that we've seen in the past, or primates, that the evolutionary path is most likely going to create these sort of fill-ins that are going on. But if you look at just a 7 million year old skeleton, or 5 million year old skeleton, you have this significant preservation. So really rare to find these types of evidence, right? Lucy bones, they were unquestionably bipedal, just with the shape of the pelvis and the location of the foramen magnum. Some adaptations for tree dwellings. So this was sort of a transitional species. They might have been just running from tree stand to tree stand, forest to forest. They were 3 to 4 feet in nature or stature. High sexual dimorphism. So sexual dimorphism means that there were a difference between males and females of the species. Probably didn't run very well. Once again, these adaptations for tree dwelling. They ate fruit, nuts, insects, and they also probably had small amounts of meat. So they were very much a omnivorous species, right? Was prey as much as they were predators. So they probably had to run. They probably had to be really tall and really smart. You had a lot taller, a lot more powerful species that were going around the landscape, including a bird that was larger than them, a falcon or eagle type bird that was larger than them. Earliest hominins, once again, hominins, Australopiths. Here's an example of that bird. You can see the tongue child. So this is most likely a child that was about 4 years old that was plucked out of whatever nest that it lived in, stolen from the mother, and then taken and fed to a nest of a falcon. And you can see sort of this reenaction of this, but it looked really sort of horrible for the tongue child. Most likely the fangs or the hooks, the talons of the bird went directly into the skull, and most likely it was transported in that way to feed the kids in a nest. So really horrific sort of end for this child, but we can see a few different things, right? Periods of nutritional stress, so hunger, at about 2.5 years, looking at the development of the skull. There was some stress. So maybe there was something like a famine or a drought that really reduced the ability of the tongue child's caretakers to deliver any type of nutrition. Early weaning age, possibly. So the idea that you no longer would be consuming your mother's milk, right? And then also evidence of cooperative breeding and care for the young, if that was the case. If there is sort of this expectation that women would not have, or females would not have, that long period of stress, possibly that was the result of a really good nutritional network that was getting formed, a really good way to deliver other types of protein and nutrition. You can also see some other Australopiths. So people are seeing these Australopiths throughout, and this is mostly in the eastern part of the continent, remember. So we have the Laetoli feet, possibly 3.5 million years before present, MYBP, million years before present. You can see here the walking of this species. It was most likely after a recent volcanic fall, and they walked through. What they can tell is that there's various sets of footprints, various individuals, and most likely the weight on one specific leg was the result of someone carrying a smaller child on their hip. And you have a reenactment there. So just thinking of all those different, just fantastic experiences and family caretaking and all those types of just wonderful things when you think about walking side by side and hand by hand with your family. And just you can think of all the different emotions that are probably loaded into this family unit walking around this sort of desolated landscape. Going and evolving past the Australopithecus afarensis, which we see is mostly around here, and there's other examples. There's probably dozens of more examples that we can use to fill in this chart, but these are mostly some of the key evolutionary paths and evolutionary evidence that we have in the genus Homo. So Bosei and Robustus, if you can sort of pick through the words here, we have this robust form of Australopithecus, and then we have this more gracile, the Bosei form. We have some other types of species that come about, and then we have the first in the genus Homo, which is the Homo habilis, or man the tool maker. Homo habilis was around from 2.5 to 1.6 million years ago. They looked a lot more human than any primate that existed before, for sure. And they had an increased mental capacity as well as evidence of tool use. They used tools. We don't see that in any really precise industrial way that we see in other parts of the animal kingdom. Like, okay, so chimpanzees, they can use sticks to fish bugs out, but they're not using rock tools. So here's an artistic representation. I don't know if it's sort of like half hairy, half not. It's sort of a really unique, interesting representation. But what is he doing? He is pounding a piece of stone into another piece of stone to most likely make a hammer or to make a knife. The first set of tools that we see, and it was called a tool industry. If you think about industry, just everybody making sort of the same type of thing. You have Oldowan toolkits, Oldowan, simple tools made by striking a hammerstone against a core to make a shape flake. So you have a harder hammerstone that's most likely more rounded, and you're using that to precisely chip off little flakes to make a more pointed edge. Cores may also be used, may also have been used occasionally as tools. So you think about like a scalpel, for example. You can just make like a little nice little knife scalpel to cut something if you want. So these were the types of stones, really simple, just sort of let's take two rocks and beat them together, and we're going to produce a really interesting new way to manipulate our environment. This does not mean that this was the only type of technology they were using as well. It's just the only type of technology that we have that still exists. They could have been making types of clothing. They could have been possibly using types of domestication. They could have been forming religious thought at this time as well. They could have been adapting and evolving in all these different other ways. But just the way that environmental degradation works, we only have evidence of the bones and the rock tools that they made. Then we go, so this is the earliest evidence in the evolutionary tree to see Homo habilis, and then we're going to go to Homo erectus, and that is the first hominin species to go outside of Africa that we have evidence of. We might have some evidence of Egaster, but sometimes now we sort of get to these areas where there might be sort of splitting hairs between these different species. So Homo erectus, once again, this is sort of a glued back together skull. We didn't find a whole skull perfectly in nature, but we found a lot of its chunks. And so what's that? We are able to extrapolate largest skull, that brow ridge, those occipital lobes are going back. you see that the brain is getting larger, the teeth are getting smaller, the jaw is getting smaller. And there's evidence of Homo erectus living 1.6 million years ago to 300,000 years ago, so a million years. It was a species that existed for a million years. If it was a unique species other than what we are nowadays, it was a very dominant species. But we start seeing primates and anatomically modern humans dropping a lot of those characteristics. So Homo erectus or agaster, erectus would be the species that left Africa, and then we see the species agaster, which most likely stayed in Africa, and that was most likely the species that we evolved from, opposed to erectus species, which wasn't necessarily in Africa where anatomically modern humans emerged. So erectus agaster probably emerged about 1.8 million years before present. A few other estimates we've seen evidence of a quick expansion out of Africa into East Asia and Southeast Asia. So we can see, for example, India and the Middle East. Some argue that Asia derivative should be erectus and Africa should be agaster, just because we have one group of individuals that never left Africa, and those are the individuals that were most closely related to anatomically modern humans, fully committed to bipedalism, using their hands as tools, 900 cc brain, cubic centimeter brain. We have 1,400 cubic centimeters, anatomically modern humans. Much lower sexual dimorphism. We see sexual dimorphism slowly going away. Sexual dimorphism among humans is very limited when compared to any other species, even including dogs. Larger, more cooperative social groups, more meat in the diet. Thinking about why are they moving around? Maybe they're following the meat, and they use fire possibly to procure that meat, to cook it, or to ward off competitors for it. And then we see a new type of tool emerge about 1.4 million years before present. So this is Homo erectus, not Homo habilis. Homo erectus is going to be innovating the Ashluin tool industry. So a little bit more pointed, a little bit more precise, a little bit more complex. Then we have the Naratomi boy. So this is possibly agaster, possibly erectus. It was found in contemporary Kenya, so that would be the population that stayed in Africa. And we can see a nearly complete 12-year-old boy, so adolescence or puberty, leading up to this very important age. And most likely what we can see, he died on a riverbank. And most likely he was wading across the river and maybe found a competitor out there in the wild, right? A different animal that did not want him to cross that river. But what it's really significant for is just seeing this important adolescent moment in the skeletal structure, as well as just the near completeness of this. You know, if we can extrapolate just some pieces of those hands, right? We know, okay, maybe we can deduce what other parts of the hand look like, and we can see the forearms, and we can see a femur, and we can see all these different really important elements. And if we can deduce what the hands look like, even though we don't have any feet, we can probably deduce what they look like, get some really close estimate. But even then, once we start putting all those pieces together, these are two different representations of what the Naryakotomi boy possibly looked like. Very different, just facial structure, very different poses, right? We sort of impose a lot of our social understanding on what's happening at this time. So, were they wearing clothes, right? What were they doing? Did they have these tools? Did he have a spear with him as he was going around this river, right? What was happening? What evidence don't we have to fill in this blank? 1984, the bones of an 11 and a half or 12-year-old boy were found along a dry canal west of Lake Turkana. So it's sometimes called the Lake Turkana boy as well, but most likely it was on the similar shoreline at the time. So just comparing the Australopithecus afarensis to Homo erectus, we can see unbalanced head versus balanced head, narrower shoulders versus lower, wider shoulders, lower center of gravity over the hips, wide chest, narrower chest. Don't need as wide of a chest because we're not lifting as heavy things, maybe. Just sort of spitballing here. Short, wide waist compared to a narrow waist, one that's made better for bipedalism, right? Thinking about energy efficiency. Small gluteus maximus versus a big gluteus maximus, not shown, but the Gluteus maximus is the butt in colloquial phrasing. Long femoral neck, so that would be the part of the femur that goes into socket, versus a short femoral neck. So possibly the Australopithecus is more like the chimpanzee. There's more flexibility around that hip region, whereas humans are encouraged really just to have this sort of piston-like motion. And then long Achilles tendon versus a shorter Achilles tendon, possibly to help reinforce the piston-like nature of our feet. Tale of two species. We see the African agaster. Agaster migrated out of Africa almost as soon as it emerged. Possibly it went extinct. Possibly there was this back and forth, an ebb and flow, and then that population that went back and forth. So Egaster is the African species. It migrated out and became erectus once it migrated out. Maybe the erectus species migrated back and forth. We just don't have evidence of what exactly that flow might have looked like. And possibly the species that left Africa and came back, those were the actual descendants, and they just died out in other parts of the world. So, there's all these sort of ebbs and flows, and we see this in modern human migrations as well. You have the Homo heidelbergensis. This is one of the first that you find in Europe. So this is showing that Homo erectus, or a transitionary species from Homo erectus to anatomically modern humans, making its way up to Europe. We see that it was found in Spain, Sierra de Atapuerca. This site is thus far yielded 5,000 fossils of hominid remains. So it was sort of a big pathway for a lot of different species. And what we see is a almost complete skeleton, or a complete skull coming from this region. And this one of the best preserved skulls from this 500,000 years ago period. So you can see something that looks very different. Gracile features, jaws getting smaller, brains getting more dome-like. You see that the jaws pushing in a little bit more, and those occipital cavities are growing. Once again, Ashlowian toolkit, they were still carrying this. So larger tools, more specialized, exemplified by the hand axe. You can see this isn't just a club, but it's an axe. Later versions of hand axe would emerge, suggesting a guide tool creation, or different elements of symmetry that were very highly prized, right? Symmetry was important, and you can see sort of most of these have a pretty strict symmetrical shape. Other composite tools we see emerging during this period as well. So it's tools shaped with multiple components. We have not just the point, but also a shaft, possibly used to fix onto a spear or atlatl thrower. Once again, a tale of two species. So then we see Erectus remained in extreme Southeast Asia until as recently as 20,000 years before present. So it became sort of this extinct species, and it still existed. There was a group called the Hobbits, or the Homo floresiensis, and we'll talk about those in just a minute here, but they were the last surviving Homo erectus. The Homo heidelbergensis was in Eurasia, parts of Israel, as well as southern Europe, and they most likely gave rise to anatomically modern humans as well as Neanderthals in some way. And the Homo heidelbergensis very likely migrated extensively throughout Europe and East Asia, and possibly went back to Africa. And they were most likely hunting like buffalo and mammoth and other huge species, and just trying to get a whole bunch of protein. Now we're getting really close up to the realm of Neanderthals and Homo sapiens. Have this out of Africa theory, once again, just sort of reiterating what we're looking at with the Heidelbergensis. About 1 million years ago, we're not exactly sure. There's sort of this fake term, Homo antecessor, sort of the earliest human migrant out of Africa, or earliest pre-human ancestor out of Africa, possibly evolved into Neanderthals. The remaining Homo antecessor then became Homo sapiens, which then migrated out once again out of Africa. So we see a bunch of different migratory paths out of Africa and a bunch of different species that are competing with one another over this time period. And just thinking about some of these processes, we'll get into the Neanderthals next week a little bit more. But what we can see are these traits. And one thing we're going to talk about a little bit next week is what happens when people look a little bit like Neanderthals. What happens when we have some Neanderthal DNA specifically coming out of Europe and Asia? What does it mean when we have these very specific subsets of humans then that emerge after we outcompete other types of humans? And this is just sort of a really interesting evolutionary function that we can just remind ourselves of time and again, the founder effect. So a small group of individuals, a small set of the population with a small degree of genetic variation goes off and starts their own colony. And what stays behind might be a much more genetically diverse and evolutionarily plastic and elastic set of people. You see in that colony, there is no representation of white butterflies. So then that means that, according to this sort of fantastical butterfly example that's on the screen, the black and orange butterflies will pass along their evolutionary traits, their genetic traits to their descendants, whereas the white butterfly will then no longer be able to pass on in that specific population. And we can see this in a few different ways: blonde haired people, blue eyed people, red haired people. I consider myself to be one of all of those. They only exist in a certain part of the world. And possibly redheads and blondes and blue eyed people are going to die out within the next few hundred years because we have a great deal of miscegenation going on between different races of individual people from different parts of the world. So we have less of that founder effect. And the part of the world where we see redheadedness take place is no longer as isolated as what it once was. So imagine if we go back 20,000 years, a group of redheads make their way up to England and to Scandinavia. You're going to see a very limited amount of people sort of circulating and interbreeding with one another and spreading along those redheaded genes. And then when we get to the present, if you go to places like India, England, and Scandinavia, you're going to see people from all over the world, like India and the Middle East. And it's no longer going to be that sort of racially isolated population where redheads are just sort of making more redheads over and over again. So this is just something to think about. We're going to talk a little bit more about Neanderthals next week. But you see here that Neanderthals most likely had red hair. And it was a different type of red hair than what we see in that population, that founder effect population that is in the northern part of Europe. So it's just really interesting, right? We have this sort of place where Neanderthals were, and we have this place where there's a high proficiency of, or a high consistency of redheads. So what is going on? But they've mapped the genome. They know that for a fact that the redhead that exists in humans, anatomically modern humans, is not the same genetic variation as the type of redhead that created red hair in Neanderthals. And you can see here a sort of an anatomically modern human reinterpretation. That red hair definitely looks like dyed red hair. No one has that type of red hair in nature. I know plenty of people with red hair of all races. That is not a color of red hair that we see in modern day society, unless it's like dyed or something like that. So at least one example of possibly if humans descended from Neanderthals or if humans interbred with Neanderthals, at least for this founder effect example, it might just be very coincidentally that these two species had a co-evolutionary moment where there was just similar evolutionary forces creating the similar type of evolutionary trait. And the last, once again, talking about this Homo floresiensis, or the Hobbit, we can see that they existed. It was found during the launch of all the Lord of the Rings movies. So the Hobbit became this really sort of go-to way to publicize this find. But in 2003, They were on this little island and they found this little ancestor to the Homo erectus and possibly even earlier species, but it was an island species, so it got really small. Normally when you're on an island you get smaller, you don't necessarily have that ability to sustain large protein mass like you would on the mainland. So almost half the size of Homo sapiens. The pelvis is like an Australopithecus afarensis, so very similar to Lucy. Long feet compared to the length of humans, short legs make the arms appear long, and then shrugged shoulders that face towards forwards, right? So you sort of have this mix of different species. It's definitely not a chimpanzee or an orangutan, which now lives in the orangutans living in that region, right? It's definitely not a human, and it's definitely something that's very similar to a very short Homo erectus. So, in conclusion, the question is, are we still evolving? And we'll talk a little bit about this next week when we look at Neanderthals. Some parts of Africa have seen an increase in the frequency of a gene called CCR532, which protects against HIV-1, but it also may have been selected for during the bubonic plague. So we see that because of one plague in Europe, where the gene that helps to sort of insulate against the bubonic plague emerged, we see that it also cancels out this immunity to HIV. And we can see a few other different elements. We can see that the development of sickle cell anemia in tropical regions, specifically tropical regions that have malaria, are pretty common. So sickle cell anemia is a blood disease frequently associated with African Americans, but not all regions of the world that live in malarial zones where malaria is common are African American. And so this sort of is a stigma that African Americans might have. And it's one of the really good examples of how humans are still sort of adapting and evolving to their environment. So that is all I have today.